Good morning, mathematicians. It is Tuesday of week 12, and let's get started with question 1. Candy bar has 4 identical boxes of candies. One of the boxes is shown below. What is the volume of all 4 boxes? So I'm going to calculate the volume of this, and then once I know its volume, I'm going to multiply it by 4 because I actually have 4 of these. Well, I know that I can multiply the length, the width, and the height to find the volume of this shape. I have a length of 4, I have a width of 2, I have a height of 3. Okay, well, I know that 4 times 2 is 8, and 8 times 3 is 24. So one of those boxes is 24 cubic centimeters, but I don't just have one of them. How many do I have? I have 4 of them. So I really need to take 24 times 4 to get my overall answer. 4 times 4 is 16. Here's my 6, carry my 1. 4 times 2 is 8, plus 1 is 9. My answer to this question is 96 cubic centimeters. Let's go to our next question. What is the volume of the below figure? Now, what is unique about this figure is we don't have the length and the height listed. What we have is their area is this. So the area of this face equals 64 centimeters squared because this is area. Now, what I need to do is I need to think about the area of this face, and I need to multiply this by the width, because how many of those layers do I have? I have 3 of those layers. So really what I have to do here to calculate the volume is I have to take the area of this face, which is 64 centimeters squared, and I have to multiply that by 3 because I have 3 of those layers. Well, let's do 64 times 3. We have 4 times 3 is 12. Here's my 2, carry my 1. 6 times 3 is 18, plus 1 is 19. So my overall volume here is 192 centimeters cubed, and I'm going to write that on my answer line. And now we're finished with question number 2. But we're not finished with volume. We have more volume as we keep going. This says, what is the volume of the figure below? Well, we have almost like a pencil box, right? This prism A, maybe it'll be a good little pencil case because we got some pencils in there, but certainly this is very small, isn't it? We have a length of 13. We have a width of what? Well, I only see the height labeled here. I see the width labeled right there. So I'm going to assume that this also has a width of 2 inches. So I'm going to go ahead and write a 2 there. And then what was the height? The height was 2. Okay, and that one is labeled. So now when I take a look at this, I have 13 times 4, which 13 times 4 is 52. So prism A is 52 inches cubed. Now, this is just the volume of A. We still need to do the volume of B. The volume of B is going to be much smaller. We can see that difference. This has a length of 5. This has a width of 2. And it has a height of what? It has a height of 2. Because take a look. The height of both of them is 4. And we've already used 2 of those in prism A. So the height of this is also 2. I'm going to multiply these together. I know that 5 times 2 is 10, times 2 is 20. So I do have a volume of 20 inches cubed for prism B. So now I have to take this 52 and this 20, and I have to join those together to get my answer of 72 inches cubed. Now, that is great, but we're still not done, are we? We still have more to do. So let's go ahead down and let's do some more volume. We're not leaving behind volume yet. Got a little bit more work to do. I am going to use um, a smaller pen. If you have a sharp pencil, you'll want to use that because we're going to have some very fine lines here. Some very fine lines here. When I take a look at this very top face, I see that I'm going to have 1, 2, 3, 4, 5. I'm going to have 5. I'm going to kind of turn it sideways because these are very small. It's difficult to do this accurately. I see, let me judge here. Okay, I'm going to have 1, I'm going to have 2, 3, 1, 2, 3, and then this is going to be 4, 5. So those are very small. You're going to end with 5 cubes right here. Now let's go ahead and let's do the cubes this way. Let's go ahead and focus on this face for just a second. And we're going to have 1, 2, 3, 4, 5. We're going to have 5 rows here. So I can join these together. I can join these together. I can join these together, but I'm certainly not done. I've got 1, 2, 3. I'm going to have 4, 5 there. So I see 5 rows going this way. Now what I need to do is I need to make 5 columns going this way as well. So here we've got our 1 that connects up there. We have our 2, which connects up there. We have our 3, which connects up here. And this one, see this very small hash line? That's where you can see that there is another one there, even though it's very, very thin. Okay, it's hard to see, but that's okay. So we did have 5 columns and we did have 5 rows. Now, I'm going to go ahead and connect these in order to make, there we go, the rest of my cuboid. Now, this is like one layer, but it's stacked on itself vertically, right? We need to determine the volume, but the key here is saying we really have one layer. It's like a vertical layer, like a slice of bread standing on its end. But if I look here at the fact that there's 5 here and 5 here, well, 5 times 5 tells me what I need to know that there is an answer of 25 cubic units here. Okay? Now, one more question for Tuesday. And what we're going to be doing, what we've been practicing for a couple weeks now. If I multiply my 5 times 1, I have 5, and my denominator stays the same. That's a procedure we can now use because we've practiced this so much. 5 times a half gives us 5 halves. Well, 9 times 1 seventh gives us 9 sevenths. 20 times 1/18 is going to give us 20/18. And 42 over 1 over 33, or 42 times 1/33 is going to be 42 over 33. Well, that finishes out our Tuesday color for today.